the next speaker is Bruno Pastoriza, who will present on fundamental concepts in chemistry education, a problematization. Please, Bruno, and apologies for because I was too long.
Okay, I was muted. Can you hear me?
We can.
Okay. So thanks for the presentation. And hello, everyone. I'm the Professor Bruno Pastoriza, and I'm pleased to present to you in the symposium the investigation that my research group and I have developed. And our title is Fundamental Concepts in Chemistry Education, Problematization. Let's see to change this slide here. I started my presentation saying that I'm very sad for the actual situation of the pandemic. I'd like to be at Argentina now. But here in Brazil, we have a large number of deaths, and we hope that the vaccination will control the situation, the sad situation. And okay, besides that, science goes on. Our researches are going the mode we can go. It's sad, but this goes. Here in Brazil, had more than 500,000 people who lost their lives, and I sincerely expect that this will be very soon resolved. And okay. So since we had sessions with the researchers from different countries, allow me to introduce the context of the investigation of my group and I. We are from Rio Grande do Sul, a state in the south of Brazil that borders Argentina and Uruguay. We do our research in the Federal University of Pelotas at the Chemistry Teaching Laboratory, which in Portuguese we say Laboratório de Ensino de Química, and we call it LABEC. As is very common in Brazilian city, Pelotas is a beautiful and pleasant place to live and work, and I'd like to invite you to visit us when the pandemic ends, of course. And at LABEC, we conduct researches that concern the general topics in chemistry education field, from discussions about chemistry teacher training and didactics, to curriculum and the history and philosophy of science, especially in chemistry. And although we aren't a group with a specific focus on the philosophy of chemistry, the philosophical discussions with emphasis in the epistemology are implemented with this articulation of the group and our action in the investigation. So I start this study with mention two studies in general science and science education that points to the production of school knowledge that differentiates this school knowledge in complexity level, fundamentals, and other characteristics from knowledge produced in scientific research and other areas. So the polygon at the screen represents the articulation between some, but not all, possible relations in chemistry education, chemical science, school, environment, economy, ethics, society, and other levels of our objective and subject lives. And when I cite the relations, I make this to highlight my comprehension about the complexity of the insertion of science in the different process of our lives, and especially in the school. In the sense, I want to highlight here the relations between the school, the chemical science, and what we may say the chemistry education. With this, I want to emphasize the school education and its relation with the scientific knowledge. Even though in a broader way, common sense can be assumed as a legitimate way of thinking, when you look at school education, have some specification and different levels of legitimation. In terms of chemical knowledge at school, is as a benchmark to our work, as a systematized form of knowledge. I mean, at school and in general, in chemistry classes in specific, scientific knowledge is assumed as the reference of work and to its formal process of organizing knowledge. So I'm not saying that we make scientific knowledge at school, please, but that this knowledge is our benchmark. And at the screen, we have the representation, a possible representation of this. Then the importance to discuss the articulation between scientific and school fields and knowledge are problematized in the research that I and my group in LABEC developed. But there is a problem. Our discussion isn't about the education or the school as a whole. We are discussing the chemistry and its function in this process. So I would like to point the chemistry education action. Therefore, if we problematize knowledge, relations, some of the questions that we can make here is, what's chemistry education for? The first question I think we have to make. Or in another way, and assuming that in the time I have in this presentation, I have to synthesize my argument. And one of the difference between chemistry and other areas is the concept of framework that we have in chemistry. We can derive this upper question in what are the fundamental concepts in chemistry education? And this isn't a new question that my group and I have made. Many other researchers have made this question, have published articles discussing its focus, etc. However, the question of what the fundamental concept in chemistry education is a problematic question because the definition of fundamental is a problematic one, and there is not an objective definition about it. Mainly because this definition can be dependent of the first time we've made. What's the chemistry education for? So to overcome this problem in our research, we've decided to define the notion of fundamental, assume that those concepts that are most investigated could be adopted as a possibility of fundamental concepts, since they can express a dynamic process of needs of problematization of the chemistry education area. In other words, when some topic is further investigated, it can be assumed as more fundamental to the group that discuss it. Of course, we had limitation in this filter, but we can talk about it later, and assume that to define the fundamental concepts, which was the most investigated in the field. Then after choosing our limits of investigation, our methodology was taken as a documental analysis through knowledge repositories, the Web of Knowledge, is Web of Knowledge, Google Scholar, and the Portal de Periódicos ACAPs, which is a big repository we have in Brazil that's fed by several publishers like Springer Link, Elsevier, etc. And to analyze the data, we proceed the contrastive analysis, which is constituted by a process in which the work team from question, themes, or other guide principle, in the first time analyzes individually each material to construct categories, notes, and descriptive interpretation. And after that, you make a group analysis to construct new categories, notes, and other descriptive interpretation in a positioning that emphasizes similarities and clarifying discrepancies of individual analysis and permit us to make some consensus about earlier constructions. So this contrastive analysis was guided by these 5 topics, and which I'll focus in the this presentation. In the first of them, is the central concept of discussion, although my group and I have also discussions developed with all the 5 topics. Within the repositories, the use of search terms as chemistry concept, conception, education, educative, review, epistemology, epistemological, and other variations of search terms, we've obtained 693 productions And after that, in our preliminary analysis, we have selected 462 texts. And analyzing them, we've identified 62 different concepts and more than 100 sub-concepts. So the table at the slide summarize the idea of organizing by constructive analysis the notion of concepts that are recurrent in the investigations and its subtopics and key terms of specification. You can see chemical bond as the concept more recurrent in the investigations, guided by structure of matter, matter substance, etc. And if you need, we can come back later in this table. The analysis led us to many points of discussions when emphasized the fundamental concepts that we have said. Here, I'll cite three ideas from the analysis. Then you can call the Ouroboros principle, the relation between teaching and chemistry, the teaching of chemistry and the philosophical concepts of transcendental and ontological ideas, and the question of the echoes of research investigations and the school, which is an unfolding of the second topic. The first point of the discussion is the relation of ideas that outline the recurrence in the concept as a tool of stabilization of the concepts. But also, you have seen the stabilization as a tool for recurrence. For example, do investigations show the teaching of atomic orbitals as a fundamental concept because it's a very recurrent concept to teach, or as it's a very recurrent concept, it must be taught? The same can be found about other concepts like enthalpy, pH values, and others. What makes this central? The recurrence itself, or because it's usually to teach, they must be taught. I mean, the justification of teaching them aren't clear. In many cases, there is not an assumption of importance to teach. The concept is taught without problematization or justification, and its importance is much more guided by its use of presence than an intentionality to teach it. So it seems the snake that bites its own tail, the Ouroboros principle. Then the large number of investigations which assume the problem of learning in terms of strategies adopted don't problematize the chemical concepts to teach. And this led us to remember the ideas of Kant transcendental concepts. I mean, the chemical concept would come as something prior to experience that exists without problematization, almost in a transcendental notion that we can borrow from Kant. Could it be possible? My group and I are analyzing this possibility in the terms of the didactics, the teaching of the chemistry concepts. As the same as the ontology, some concepts are taught as if the chemistry teaching could not exist without them. For example, chemical bonding, the structure of matter, as well as chemical reaction, periodic table, but periodic table, not the periodicity principle, the periodic table, and so on, are present in the class, in the studies that we've analyzed, are presented in the class as they couldn't be questioned, or as we analyze in the many texts, the teachers can think they're teaching without a lot of concepts, that we can problematize its fundamentality. And, for instance, the third point is the lack and low effect of academic articles under school conditions of teaching and learning processes. At the first session, for example, Professor Eric Serri talked about the problem of acidity in Lewis theories in relation to Arrhenius and Boss-Lowry theories. In a certain point of the presentation, Mr. Serri questioned why the nostalgia for acids in the layperson sense of assets. And if I could say that we have a complex problem to solve. The recurrence assumed here as a way of highlighting the fundamentality, reinforce some inexplicable relations that can be saw in academic productions, but didn't arrive at school. What's our task as philosophers, teachers, researchers of chemistry? My final considerations are organized in 3 points, two here. First, we have a constant battle among tradition that we emphasize as the recurrence, and our intentionality at teaching some chemical concepts. Can we fight this battle? The second idea, we can also observe a lack of epistemological discussion in various teaching proposals. And when I say epistemological ideas, I refer to with the historical ideas. And as I think the necessity of problematize the relation of stabilities in chemistry education and the assumption of them, as all of them were transcendental and ontological themes, which I think they maybe not. For example, these stabilities led some ideas in the teaching of chemistry. I'm talking about the teaching of chemistry, like it was a fixed concept that without them, the chemist can be taught. For example, I mentioned the bonding, chemical bonding is one who knows fundamental idea, maybe. But for example, when a lot of teachers talk about periodic table and the periodic table as the square of table, there's a problem. Is the periodic table a fundamental concept? I don't know. And I would close this problematization thinking with some questions we can make from this analysis. For example, can we talk of teacher and school autonomy in choosing what to teach? What's central? What's fundamental? What's a need in the chemical education? Is it the problem of storytelling view, for example, without epistemological discussion? I mean, in many concepts we teach, we have ideas established without discussion, without knowing historical, philosophical, and especially epistemological aspects. This is a problem. I usually make a storytelling of a fact, of data, of isolated concepts. Is it a question of knowing models in science classes, or is it a question of problematize the basis of what chemistry is? In other words, we come back to our main question. What is teaching and learning of chemistry for? With this problematization, I'd like to thank your attention, thank to FAPERGS and CNPq, the Brazilian research funding agencies, and to my group of investigation, especially to my students, Fernanda Dutra da Silva, Rodrigues, Laura Bardini, Brahm, for this investigations, analysis, and thank you for your audience. We can make some talk, and I would be glad to answer your questions. Thank you.
Thank you very much, Bruno. Now it's time for questions. I think that Olympia has a question. So please, Olympia.
Thank you for your talk, Bruno. I'm sorry because I think that I missed a point or a detail of your talk regarding the statistics you made. Which kind of journals you used, and with which criteria have you used to select them? I mean, first I missed this. They were chemical journals or education in chemistry journals. This I missed, and also which were the criteria, because the statistics may change a lot.
Yes.
Depending on that.
Yeah. First of all, we investigated in the chemical education area. So we selected some journals from chemical education in those repositories. So the first criteria was journals in our area of investigations. After that, the second criteria I can say is productions in chemical education area that focus on discussing concepts of chemistry. And this discussion could be to propose some practice, to discuss some experiment, to discuss some concept in specific. And then in this area, you had many kinds of investigations, and with these investigations, we analyze them to categorize which concept was the focus of the article. Of course, some articles talk about 1, 2, 4, 3 concepts differently, and we have categorized each concept that was cited was pointed as one. So, for example, one article that talked about chemical bonding and enthalpy was pointed one category in chemical bonding and other category of enthalpy.
Okay, thank you. Very clear.
I'm sorry, but with the time we have synthesized the idea, and this passed up from the presentation.
Thank you, Bruno. There's another question by Michelle.
Hello, yes, thank you for your talk. You started and you ended with the question, what is chemical education for? And I was just curious what you thought the answer might even look like. Because if you think about such a question, it would be silly to say it's in order to make good lab technicians, or we want to make brilliant chemistry scientists, because not everybody can be a brilliant chemistry person. It might be to help people navigate around the world in their daily things. What sort of cleaner do you buy, and you realize that this one is actually very poisonous, etc. So there might be many, many different reasons to educate people in chemistry. So I was just curious what sort of answer you were looking for.
I think that I agree with you that there are many forms to answer this question. But specifically, when we think about the teaching of chemistry in schools, for example, and my area of the didactics, we think about a lot about this question. We need to know we don't teach for make scientists, mainly in our contemporary days. So here in Brazil, there's a thinking, there's a large thinking in the schools that we have to teach to form the citizens. And the idea of citizens is a large idea with other concepts involved. So I think we have to answer the question thinking, how can chemistry allow me to read the world, to make some decisions in the world that can contribute to my my daily life. So this is very important when we analyze the chemistry. And for example, and Elena had talked earlier about that. Orbitals or quantum chemistry at school, there is a problem to teach this kind of concepts, because it's very difficult to use these ideas, the concept, for example, the concept of quantum chemistry at the school to explain the world, but not the philosophical idea of which what is the quantum world, the ideas of that problematize the matter. So I think this notion of read the world to make decisions, to think about how can I explain what is surrounding me with the chemistry is a good answer, or I think a possible answer to this. And this can guide our choices in chemistry teaching. Unfortunately, a lot of investigations we have analyzed didn't discuss these ideas. A lot of investigations don't problematize the chemistry concepts. A lot of times we don't have a problematization, and sometimes have they as a truth well established, like chemistry bonding, chemical bonding is definitely that concept, is definitely that idea from Lewis. There's as we didn't have another idea or another concept, and I think this is a problematic one, a problematic view of chemistry, because it can't open our mind to other models, other possibilities, other chain of models. So I think is a possible answer is that, but it's not the answer, because if I made that, we are reducing again the idea.
Thank you so much, Bruno. I must say that I agree completely with you when you say that we don't teach to make scientists, we teach to make citizens, at least at school. Anyway, I think that time is over and we should go to the next and last presentation for today. So thanks again, Bruno.